Tcl. This is actually a tip. And since I was following Cliff, I decided to do a colorful theme for my slides. Okay. Okay. What is unit testing? Is what I'm first going to talk to. We kind of do a level set, and we all on the same page here. Why unit testing? I mean, why bother? You know. Talk about why do we need a framework beyond the pieces we have now. I'm going to go into some of the details in the tip, and I'd like to get a discussion going where to go from here. We can talk about it also tonight, tomorrow night in the room, at lunch, etc. But do want to get a little bit of discussion going because I haven't heard much of any feedback from the tip, so I want to make sure we get it right when we add it in. Okay, what is unit testing? Also known as white box testing. You know what's inside the unit. You want to test the smallest units you can of the software. In our case, that means procedures and methods, if you're using tcloo. Okay? You want to test all the code paths for the units, even the ones that involve failures, because, you know, we all test a kind of happy path, but when you go to read from that file, and it's the disk network connection went out and you get an error, well, gee, I forgot to test that, and oh, I have a syntax error there, and it just kind of blows up with an ugly message instead of printing a nice message to the user. You don't want that happening. And these are some of the same things Cliff just said about commercializing an application. You want to test in isolation. You don't want to have you want to have a known set of data you're testing with. You don't want to have to say, oh, did I remember to reset my database to these values? Or, gee, somebody edited that web page that I was using to pull off of, and now my test fails because it's not getting the expected data back. You want to have a known state and controlled reactions. You want to be able to generate failures. And feel free to stop and ask questions in the middle. I don't have a question slide at the end. I'm expecting y'all to kind of interrupt, please. Okay. Again, why unit test? This is what's called a testing pyramid in computer science. And unit testing's at the bottom. If you do a good unit test, it's covering 100 or at least near 100%. When you do component testing, you're exercising components, but it's covering less space. Usually, some of those error cases don't get that because they're very difficult or impossible to generate. When you do integration and system level testing, they cover less and less. And exploratory testing is what your beta users do, or you do just poking around. So each of these levels cover less and less. Now you can automate a bunch of these levels, particularly unit testing is usually has to be automated. Exploratory testing is more or less generally all the time manual. There are some tools to do like random poking at it, but in general, as the higher level you go, the less it might be automated, and the more chance it's going to be manual. And the unit testing that we're talking about fits in at the automated tests. So, why test again?
Gerald, on the previous one,
Sure.
where does fuzz testing fit into that?
I haven't heard that exact term. Can you explain what you mean, fuzz testing?
Well, this is all the rage, where you take an application and just hammer it with random inputs, or not.
Generally, what I would say that's in the exploratory testing towards the bottom of that pyramid. You see how this line right here kind of cuts across? That would be the fuzz testing with random inputs there.
Let's talk about fuzz testing later.
Okay. But again, this tip is focusing on unit testing, way down at the bottom. Okay, why unit test? As Cliff said, a lot of these days, especially if it's a cheap app, you know, they're not paying $1,000 for the app. It's a $20 app or worse yet, on an iPhone. Apps sell for $2, $4, $5. they hit a bug, I'll throw it away and go get another one. They're not going to come back to you. So there also customers don't like it, so they'll throw away your app. Or they'll pay more if an app has a lot of good ratings and doesn't have bugs. It costs money to a customer when the functions are not available. They have to go do it themselves, or like I said, they'll go buy another app. Depending on your space, it could actually lead to audits or fines by the government or your customers. Again, that's obviously not in the iPhone or phone space, but in some of the commercial spaces where you're doing accounting stuff or you're tracking, did somebody do what they were supposed to be doing when they were building something like an airplane? That could lead to big government audits or fines. Also, it reduces your total life cycle cost to you. Bugs cost money. Any way you look at it, they cost money. They cost money in the sense they cost you time to find and repair those bugs. Plus, they cost money in the fact that if you have a product out there that's getting bad reviews, oh, it has these bugs, it has this bugs, that's going to impact your sales negatively. It takes anywhere from 5 to 10 positive reviews to offset one negative one. Okay? The later a bug is found in the development process, the more costly it is to fix, because it can have side impacts and all. So the earlier you find it, as soon as you introduce it, the easier it's going to be to fix. Because one thing is, you forgot to why did I do that line of code? What side effect does it have over here or over here? Oh yeah, so it's much easier if you write something, you test it, it shows up it passed or it failed, okay? And obviously, if you're taking these funds that you have to fix bugs that you could have avoided in the first place, you don't have them to use somewhere else, like adding more useful features, or getting a bigger bonus, or having a really nice dinner, okay? So you don't have the funds available if you're using them up. And funds in that case might also mean time. If you're sitting here trying to find this bug, fixing it and all, you might not have time to go out with your friends, or go out with your wife, or go see your grandkids at their football game. So any way you look at it, where if funds might not be a dollar amount, it might be just your time. But that's a limited fund that you have. You can only use once. Okay, the tip proposes to enhance the Tcl test suite by adding support to make it easy to create mocks and scenes. A mock or a stub is, say, you have this command or procedure out there, we're going to put our own test stake in so we can control how it reacts. A scene is where you have this big legacy piece of code already because you didn't start writing tests to it until, kind of after it was out there, or maybe you inherited it from someone else. And we're going to take a section of code, put a seam in that we can, in our testing, just say, don't actually execute all that code, just set these values, so do these values here. Okay?
Gerald?
Yes?
So those three terms, could you provide just a little bit more description?
Yeah, I'm sorry. Okay, a seam is basically if you think of taking a whole big block of code and saying, I'm going to call this a name seam. And what I'll do is I'll say, in my test, I don't really want you to run all this because it was too complex to write tests and all for. Just have this whole section for this particular test path. Return a value of 5. Set this variable a value of 5. That's what a seam does. A mock or a stub says, instead of calling the real routine puts, call my stub that's going to, in the second time you call it, and I'll get into that in a little more detail, will return an error that, file unavailable, okay? Which might be very hard to actually have happen while you're in the middle of doing a bunch of puts to a file, or device fault, to make sure you handle those type of things. So a micro stub replaces an existing procedure command, because they're all the same in Tcl to us, with something that's very carefully controlled by you to make it execute those error paths or success paths in your code.
And what's the difference between a mock and a stub?
None. They're different names for the same thing. In the literature on testing, some people like to use mocks. Some people like to use the word stubs. So, not knowing what the audience was, I tend to use both. Okay.
Gerald,
Yeah.
maybe I'm jumping ahead of you here then, but clearly in Tcl, being able to redefine a command is a trivial operation. So the implementation of what you're talking about is not difficult. And
Right.
in the Tcl test package, with the ability to have a setup and a cleanup stanza in each test, what's missing?
Well, I'm glad you asked that because we'll be answering this slide or so, okay? But why the tip? It basically is going to make it easier. Yes, you can do the rename, but the easier we make it for people to do the testing, the more likely they are going to. You, practice that on this side? I'll just talk about it. What it really adds is it makes it easier. You don't have to do the rename and figure out, oh, I'm going to rename it to this space where it doesn't conflict. It just makes it easier to do the renames. And instead of having to write the proc, as you'll see in a minute, it allows you to easily define the behavior for the first call, second call, etc., of the thing you're mocking out or stubbing out. So yeah, we could do it all in Tcl. And it's all done in Tcl. It's Tcl code. It's a convenience thing to make it easier. Because the easier we make it, the more likely people are going to you're going to write tests. If tests are hard to write, it's like, why do we have Tcl test suite? I mean, it's only Tcl code. You could have written all that. So we have it because it makes it easier and more consistent. It's a utility. That's why it's proposed to get added in. Okay, so what does the tip actually consist of? It consists of a command Tcl setup that you do once per test, and it specifies what things you want to stub out. Okay? And since I had to have under the hood an add to do individual stubs, we also have an add stub in case you forgot one. But it wasn't hard to expose it, so I exposed it anyway. Maybe it shouldn't be. We have one of the things that, because I'm sometimes affecting global variables, I have a save bars that basically saves variables. You know what variables you're going to be mucking with. It saves off the content so that when in the next slide we'll see about a cleanup, we call it a cleanup. It goes and restores all the procs back to where they were. It restores all the variables to what they were before you started running any test. The save test setup is basically to define a bunch of procs at one time. Save bars will save bars at one time. These two are the lower level ones, and maybe they shouldn't be exposed. That's open to debate. Okay?
Gerald, I want to interrupt us.
Sure.
Would it be fair to think of these as being analogous to the commands such as make file and make directory?
Yes.
Remove file and remove directory?
Yes.
Which just take very common setup and tear down tasks.
And automated.
Reduces them to a single command rather than a whole
Yes.
collection of commands.
It's very analogous to
Otherwise,
that. Thank you,
you
Don.
have to go through.
Thank you. Yes.
Okay.
And this is aimed at test in the Tcl test suite. The Tcl test suite generally is testing the C commands. This is more aimed at testing Tcl procedures than a C command, making it easier. Oh, wait, did I skip one? No, I didn't. Okay, remember I said that the add stubs are the setup. It takes a list of procedure names and procedure data that you want to stub out. The procedure name actually consists of tuples, which is the invocation number and the behavior dictionary. Some other languages do patterns of the parameters you passed in. Well, at least with some of the stuff I was doing, that didn't work really well because I'm always passing in the same thing to gets. I'm passing in the same file descriptor, and the variable gets set. So that didn't work very well. I wanted it to work the first 4 times I called get, and then generated an error end of channel the 5th time. So I went what I'm proposing going with an invocation number that says, on this invocation, do this. And you can have star, which says, oh, any invocation he didn't specify in the list, this is the behavior I want. Now, defining the behavior is more interesting. There's a couple things. You can say use, and standard's default. If you say use, don't say use, just the standard, which is using all these other things. You can say, for this invocation, use actual, which actually calls the stubbed out routine for you. And it does it in the correct context. So it does the correct up-leveling of the call to make it right. Or you can use prefix, and prefix uses prefixed basically a script and call this other command with the same arguments. It's basically replacing the command with whatever you specify as a prefix, like a lot of the callbacks in TK work. And I'm sorry, I haven't been looking over you. How am I on time?
Quarter through, a bit
Okay.
over.
Oh, good. We're going really great then. Returns. Most of the time, you just want to return a value. Okay. So this is usually I don't have to use in my actual test script. I have return, and it returns a value. If you don't say anything to it, it defaults to the null value. Kind of a very good ticklish thing. You can say code, and it defaults to OK, but you can say error, continue, break, so you can simulate any of those things. Error code, it'll set the error code if the code's not OK. So just, the normal things we would expect returning. You can set, and this is a set of triplets, because a lot of times in TK we'll pass in a name of a variable. The procedure has the side effect of doing an up bar and changing it. So this is what the set does. You pass a variable name either in a type, either scalar or an array, and a value for it. If it's an array, it should be a list suitable to be used by array set. So basically you can simulate errors, you can simulate side effects, you can simulate returns. And you can do that by that. At the end, for the results, because Tcl test takes the result, you get the result and you compare it. Sometimes I have a couple utility function test call count. It will tell you how many times the particular stub was called. So let's say you have a loop where you're doing a reads, you're doing gets, and you want to verify you only called it 4 times, but the 5th time you return EOF or device not channel closed, and you want to make sure that you didn't overcall it and you loop because you had to stall for the other case. Okay, so you can use that in your compare as part of your result set to make sure that the call counts were what you expected. Test cleanup basically restores all the state variables and stub variables. It might be very appropriate if this tip is accepted to go into Tcl test that goes away and is automatically done for you as part of the cleanup. But putting this kind of outside and adding add-on as it is right now, it's needed. Sorted array data. If you're using arrays and you can't just do array get and pass it to the results, because the order might be changing. There's no guarantee that the order of an array, the values returned from array get, there's no guarantee on the order. So what this does is it's a little utility that I think is missing from Tcl test, and I threw it in here. It's not really a stubbing thing, but it sorts them so that they're always returned in a known order. That was just something I threw in because I was finding I was using it a lot. Okay. And this is, again, maybe it should be exposed, but it's there right now. It's called proc. It calls the real implementation. That's used basically where if you say use actual. Now, test seam is something that's different than the stubbing. It's for, again, where you might have a big legacy code that you are trying to add a new piece to, but you want to test your new piece. One thing about seams is it has to be defined all the time. So it has to go into the early initialization, not just when you're running tests. Because this is, you add seams in your real code, and they just don't do, the seam does what it does, executes the real code, except for when you activate it. So in your real code, you would do a test seam, define seam name, and then put the body of code that normally gets executed. In the test, you're going to say activate a seam name and give it an alternative body. So in your test, when it gets to that seam, it will execute the alternative body of code instead of the big body. And the usually that alternative body is just setting a couple variables. And deactivate. If you're doing code from scratch, you should never ever use test seams. You should write tests to do it. However, the reality is sometimes you have a whole bunch of legacy code out there that don't have tests that you're trying to start automating tests for the pieces you're adding. And you don't have the time to refactor it into nice testable units and write tests for everything, so seams are provided. I would not be at all upset if seams were not accepted as part of the tip. Okay? It's just the way the world is. Trying to be realistic here. Also, as part of doing the tip per request, I added an example. And I took the HTTP package that we have in Tcl, and we have tests for, and I added a tip 542 test for it. That instead of creating a little mock server and talking to it, having it talk to itself, I believe 2 threads, it basically stubs out the actual I/O commands and returns, forces error, returns, etc. And actually tested a couple lines of code that apparently weren't tested before because they had errors in them, and I submitted corrections for the errors too. The tip, this is all in a tip branch, and you can see that from how to do it. So, the big feedback I would like from the community, both those here and those listening online, wherever the online pickup is right now. So for those listening online, give some feedback. One, is this the correct direction? And this was done for procedure-based. It really has some holes for TCLO that I've knocked around a little bit with Sean and Don, but I also want, for example, how do you test a constructor or a destructor if you want to mock those out so that they don't actually create a database connection, let's say, or connect out to the web? Those aren't just procedures you can easily punt around. So I'm thinking that the test setup, we might need a test OO setup, and maybe the whole TCL test needs to be turned a little sideways for the OO ones where we're saying, we need to think about OO. We haven't been, I don't see a lot of TCL tests. We have the TCL test for the actual OO commands, but not for systems built using TCLO. And TCL tests may have to be tweaked more. I haven't gone into it yet. Yes, Colin, I'm trying.
So, what I did for that, I've encountered the same problems you have, we all have. So I've got a stub methods scope. It establishes a scope of code where code one within that has the stubs and mocks and everything else applied to that. Because one of the patterns that I needed to test was you're going to be running, the code under test will be creating instances of objects. So just for this section, I need to replace bits of the class so that the created instances are stubbed. The other side of that is I've got existing objects, a database connection instance that I need to stub out methods on and have those return to the sort of overlay, shadow the existing methods and have them return. So, I mean, I've got all that code. You can see it fits in. But what I found worked really well as an organizing strategy is this idea of this is a stubbed configuration. This is code that within this scope has these things applied and it automatically reverts to the non-stubbed version once it leaves that scope.
Yes.
I did the same thing for procs, but that's far easier.
Yeah, procs are far easier. So trying to fit inside of TCL test framework as much as possible, which is what the pros was. But I think this community would really need to look at how TCL ones we should be testing. And, you know, because the problems are very different than problems, it turns out. And, you know, Pine has an example, and we can annotate, please feel free to pull down the tip and annotate it with some proposals for O. And again, the talk was to inspire the community both here and out on the net to try to get feedback on this, because I'd really like for us to get it right the first time and not have legacy. Yes, Don?
In the interest of getting it right, let me warn you, you won't get it right.
I'd like to get it, yes.
Which is part of the reason why I've not digested everything here. I know there's a lot of work here, and you've convinced me there's an important problem here to solve. I'm of the tendency to want to minimize the changes to the Tcl test package itself, find out what customization hooks are missing, put those in place, and have most of the rest of what you're talking about available as a separate package from you.
What it actually is a reference implementation on Chisel app where all this works. The only thing is it has to get the seam in early enough. It actually modifies, I think, init.tcl.
And then when we discover where you got it wrong, it's a matter of making improvements to that side piece and not going through to get another tip.
And there is a bunch of Tcl code in Tcl that has test suites associated with it. I've got a framework, there's an HTTP server, all those are rigged with current Tcl tests. So you want to see the kind of hoops I had to jump through to get unit tests to work properly, especially with networking.
Yeah, so again, this is to try to get a discussion going in the community. And throw away the whole thing and get something better. Will not be offended by that. I have no, blood stake in this. I'm just trying to get a discussion going because I put the tip out and was.
Let me just confess, I didn't understand the tip. I understand this. It was great that you gave this talk.
And that's one reason I gave the talk, to try to make people understand. Yes, I am out of time now. Actually, I have 1 minute left, but I'll say that's out of time and let the next person come set up. Thank you all for your time, both here and on the internet, whoever's listening on the stream feed.